In the experimental setup of meter bridge shown in the figure, the null point is obtained at a distance of 40 cm from A. If a 10 ohm resistor is connected in series with R1, the null point shifts by 10 cm. The resistance that should be connected in parallel with R1 plus 10 ohms such that the null point shifts back to its initial position is. Now in the first case, when R1 and R2 are connected to the meter bridge, the null point is obtained at 40 cm. So we can write R1 upon R2 equals to 40 upon 60, that is 2 by 3. Now when a 10 ohm resistor is connected in series with R1, the equivalent resistance in that branch increases. Due to this, the distance of null point from A increases and it is given that it shifts by 10 cm. Therefore, R1 plus 10 upon R2 equals to 50 upon 50, which is the new null point, which is 1. So from here we get R1 plus 10 equals to R2. Putting this value of R2 in equation 1, we get 3R1 equals to 2 R1 plus 10. So 3R1 equals to 2R1 plus 20. So R1 comes out to be 20 ohms. Putting this value of R1 in equation 2, we get R2 equals to 30 ohms. And the new equivalent resistance R1 plus 10 comes out to be 30 ohms. So now the equivalent resistance when a resistance R is connected in parallel with this R1 plus 10 ohms, that is 30 ohm resistor, is given by 1 upon R equivalent equals to 1 upon 30 plus 1 upon R. So this R equivalent comes out to be 30R upon 30 plus R. So it is given that for this combination, the null point obtained is again at 40 centimeters. So we have R equivalent upon R2 equals to 40 upon 60, which is 2 by 3. So 30R upon 30 plus R into 30, which is the value of R equivalent and R2, is equal to 2 by 3. So we have 3R equals to 2R plus 60. So R is equal to 60 ohms.